They say everything old is new again, and that's certainly true when it comes to innovation. Sure, we've come a long way from the first rudimentary contraptions, but today's inventions often have their roots in history's earliest innovations. We'll look at how and why they were created, how they changed the world, and how they continue to shape our modern lives. First up, the wheel. Just think about the humble wheel. Invented some 5,000 years ago, it remains one of our most important creations. It's safe to say the world would be a very different place without it. It was found in Egypt and was likely used for ceremonial purposes. Another early wheeled vehicle is the Ljubljana goddess wagon, which dates back to around 3200 BC. It was found in Slovenia and may have been used for religious rituals. In this series, we're going to explore the origins of civilization's greatest inventions. In Mesopotamia, they were used for transportation, agriculture, and warfare. Roads were built to accommodate wheeled vehicles, which made it possible for people to travel long distances quickly and easily. Cars, trucks, buses, and other vehicles rely on wheels to move. The wheel has come a long way since its humble beginnings as a potter's tool. But one thing has remained constant: its ability to make our lives easier. This led to the development of road networks that connected cities and regions. It's no wonder that the wheel is considered one of the most important inventions in history. It's an incredibly useful invention that has helped humans to do more with less effort. If you did, be sure to stay tuned for more videos like this one. Its versatility, efficiency, durability, and simplicity are just a few of the reasons why the wheel is such a great invention. This simple machine consists of a wheel attached to a smaller rod called an axle. Al-Jazari, an engineer, created a sophisticated clock tower. They were initially large, public devices, but eventually smaller versions were made for homes and offices. By the 17th century, clocks were common. The Industrial Revolution in the 1800s brought further improvements. Clocks became cheaper and more accurate thanks to advances in manufacturing. The quartz clock in the 1920s was a major leap forward. It used a quartz crystal to vibrate at a precise rate, making it extremely accurate. Today, atomic clocks measure time based on atomic vibrations, giving the most precise time measurement ever achieved. It had a weight-driven mechanism, an escapement device to regulate its motion, and a way to display time digitally using pins and wheels. Early clocks helped organize daily life, predict natural cycles, and preserve knowledge across generations. Today, clocks drive our fast-paced world. They allow global coordination, instant communication, and precise scheduling. Whether it's keeping appointments, coordinating travel, or ensuring timely delivery, clocks are integral. The evolution of timekeeping reflects humanity's ingenuity and need to measure time accurately. From sundials to atoms, our quest for precise timekeeping continues. This design influenced later European clocks. Join us next time as we uncover more historical inventions that shaped our world. Wheels can be used for all sorts of purposes, from transportation to industry to agriculture. They're also very efficient. A wheel and axle is a simple machine that can make it easier to move heavy objects. These used weights and gears to keep accurate time. However, these early clocks were still limited to counting hours and couldn't measure smaller increments like minutes. They also required constant maintenance. People didn't understand it, but they needed to measure it. To plan their days, predict the seasons, and tell stories across generations, they needed clocks. The first crude clocks appeared around 1500 BCE in ancient Egypt. They were sundials that tracked the position of the sun in the sky. As shadows shifted, people knew it was time for certain activities, like planting crops or harvesting them. This efficiency has allowed humans to do more work with less effort. Around 1300 BCE, the water clock appeared in Egypt and Greece. Also called a clepsydra, this device measured time by dripping water. A container would fill up and then empty over a set period. When it refilled, it indicated a specific amount of time had passed. This was useful for religious ceremonies or court proceedings where precision was needed. The wheel is also very durable. A well-made wheel can last for many years, which means it's a cost-effective solution for moving things around. When the wheel rotates, the axle also rotates, making it easier to move heavy objects. Chariots were used for warfare as early as 2000. BCA wheel is a circular object that rotates on an axle. The axle is a rod that passes through the center of the wheel and allows it to rotate. The rim is the edge of the wheel, and the hub is the center of the wheel where the axle passes through. Different types of wheels have different features and functions. For example, the size and shape of the wheel can vary depending on its intended use. Some wheels are designed for use on roads, while others are designed for use on railroads. The material that the wheel is made of can also vary depending on its intended use. Some wheels are made of metal, while others are made of plastic or rubber. Chariots were faster and more maneuverable than other modes of transportation, so they were ideal for battle. Even in ancient times, it was possible to mass-produce wheels, which meant that they were affordable for a wide range of people. Finally, the wheel is a very simple concept. Once the basic principles were understood, it was easy for humans to replicate and improve upon the design. This simplicity has allowed the wheel to be used for thousands of years and has made it one of the most important inventions in history. The use of chariots led to the development of specialized military vehicles, such as horse-drawn wagons for hauling supplies and artillery. The wheel and axle was an important innovation because it made it possible to move heavy objects over long distances with relative ease. This innovation had a profound impact on the development of human civilization. The horse was domesticated around this time, which made it easier to pull carts and chariots. This innovation had a profound impact on the development of human civilization. Wheeled vehicles were essential for the development of trade and commerce. They made it possible to transport goods over long distances quickly and easily. This led to the growth of cities and the development of complex economies. This led to the development of specialized wheeled vehicles for different purposes, such as light chariots for racing and heavy wagons for hauling goods. The wheel was invented around 3500 BC in Mesopotamia. But before we tell you about its surprising uses, let's get one thing straight. It wasn't invented for travel. That's right. For centuries, the wheel was used only for pottery. The earliest wheels were made by potters who needed an easier way to shape their clay. They started with a simple disc and gradually improved the design. Eventually, they even developed the potter's wheel, which could rotate in both directions. This made it easier to create symmetrical pots. But the real breakthrough came when someone realized that instead of centering each pot by hand, they could simply spin it on a wheel. This innovation led to the mass production of pottery and allowed Mesopotamians to develop specialized workshops. The exact origin of the wheeled cart is unknown, but archaeologists have found evidence of early carts in Mesopotamia dating back to around 2000 BC. These carts had solid wooden wheels and were pulled by oxen or donkeys. They were used primarily for hauling goods, but they also helped move armies and spread ideas and innovations. Only centuries later did someone realize that the wheel could move carts, not just clay. One of the earliest known wheeled vehicles is the Tel El Marna wagon, which dates back to around 3400 BC by 2000 BC. Wheeled vehicles were common in many parts of the ancient world. The invention of the wheel and axle is credited to the ancient Mesopotamians. The wheel and axle was an important innovation because it made it possible to move heavy objects over long distances with relative ease. The wheel and axle was also an important military innovation. The wheel was also essential for the development of transportation. Today, the wheel continues to be an important part of our transportation system. From the earliest days of civilization, the wheel has helped us to move goods, people, and ideas around the world. So, what makes the wheel such a great invention? For starters, it's incredibly versatile. Another reason the wheel is such a great invention is that it's very easy to manufacture. There are many different types of wheels, but they all share some common features. The wheel has been used for thousands of years, and it shows no signs of going away anytime soon. In the 1440s, a German blacksmith named Johannes Guten tinkered with an idea that would change the world. While working in his shop, he built a machine that could reproduce written characters, symbols, and images onto a page. So knowledge was both expensive and rare. But Gutenberg's invention made mass-producing books possible. To understand why Gutenberg's printing press was such a big deal, let's talk about how books were made before it. Copying text was hard work. Scribes would copy text from existing books, but mistakes happen. Sometimes they'd misread a word or accidentally leave out a line. To create one manuscript, a scribe might spend months copying text by hand, making corrections along the way. Then a single book could be produced. Literacy rates rose dramatically, especially in Europe during the Renaissance. By the 16th century, about 60% of Europeans could read. That's when the invention of the printing press had its biggest impact. Its ability to spread knowledge rapidly led to major shifts in European society. Scientists like Nicolaus Copernicus used the printing press to share their discoveries. Scientists like Andreas Vesalius used illustrations to show the inside of the human body. People could finally see what the human heart looked like and how it worked. When Copernicus published his theory that the Earth revolved around the sun, he used the printing press to spread his ideas. The printing press also helped scientists keep track of their experiments and discoveries. Just think about everything you can accomplish with your smartphone. Now, imagine trying to do those things without any technology. If you did, make sure to hit that like button so you never miss an exciting episode. And while you're at it, subscribe for more fun history. Not only would it be impossible to do many of the things we do today, but the world wouldn't be nearly as interconnected as it is now. For example, scientists began publishing their findings in journals and books. He dared to dream up a better way of doing things, and his invention changed the course of history. So if you ever feel stuck or uninspired, remember that anything is possible and one person's invention could change the world. But they can also shape those things as they spread across the world. Gutenberg probably didn't realize the full impact of his invention, but without his printing press, the Renaissance, Reformation, the rise of science, and the Enlightenment might not have happened when they did. This created a permanent record of knowledge that built upon itself over time. Thanks to the printing press, scientists no longer had to keep their discoveries secret or fear that someone else would get credit for their work. But if a publisher needed many copies of that same book, they would have to pay a scribe to do the work all over again for each book. Instead, thanks to Gutenberg's printing press, a publisher could make many copies of the same book quickly and cheaply. Enlightenment thinkers like John Locke and Jean-Jacques Rousseau used the printing press to spread their ideas about government and society. But the printing press wasn't the only thing that sparked these revolutions. It just happened at the right time. European society during the Renaissance was ripe for change. Gutenberg's press simply provided the tools to make those changes happen. Locke's writings, for example, inspired the American and French revolutions. The printing press allowed for mass production of books, meaning more people could afford to buy them. Also, since books were cheaper, libraries started to pop up everywhere. There were public, private, religious, and secular libraries. Soon, almost everyone could own a book. If a mistake was found, they would have to erase the error and rewrite it. This process was not only incredibly tedious, but also expensive because of all the wasted materials. Books were pricey. For example, the printing press helped spread Leonardo da Vinci's notebooks, which contained his scientific observations, artistic techniques, and inventive designs. It also helped publish the works of ancient Greek and Roman philosophers. Their ideas inspired Renaissance thinkers to question long-held beliefs and to look to reason and evidence rather than tradition to guide their thinking. Basically, Gutenberg's invention helped Europeans shift from a medieval worldview to a more modern one. They were mostly owned by the rich and kept in places like monasteries where monks would read them aloud to anyone who wanted to listen. You see, the Catholic Church had a near monopoly on religious ideas in Europe for centuries. But once Martin Luther wrote his famous 95 Theses criticizing church practices, he used the printing press to quickly spread them throughout Germany. Suddenly, people across the region were talking about the possibility of religious change. Other reformers like John Calvin and Huldrych Zwingli used the printing press to spread their ideas too. Before long, The Reformation became one of the biggest religious movements in history. That meant that most people couldn't learn how to read or even get their hands dirty by holding a book. In fact, most people couldn't even imagine that there were thousands of other people who couldn't read, just like they couldn't picture the people who lived on the other side of the world. As a result, ideas spread more easily, literacy increased, and revolutions followed. Gutenberg didn't invent writing, paper, or even movable type, but he did combine these existing technologies in a completely new way. First, Gutenberg cast letters from molds made of lead. He placed each letter on a wooden block, aligning them perfectly. These blocks were then inked and pressed onto a sheet of paper. Each block printed one page of a book. Once a page was complete, the paper was dried, cut, and folded. Finally, multiple pages were stacked together to make a book. This was a huge improvement over copying by hand. With the printing press, books could be produced much faster and more cheaply. That's why we're calling this invention No. 2 in our series. All about inventions that changed the world. Last time, we talked about how the wheelbarrow helped build Rome and spread across Eurasia. Now, stay tuned to find out what other inventions shaped the modern world. And when he showed off his invention to the world, it caused quite the stir. You see, Johannes had just invented the printing press. Before the printing press, books were labor-intensive to produce. It took months or even years for monks or scribes to copy manuscripts by hand. Let's get back to Gutenberg and the printing press. Gutenberg's printing press would change all that. To see how, let's print a page. To demonstrate this, let's compare two different ways of making books. Knowledge is power, and Gutenberg's invention gave people the means to obtain it. First, it helped kick off the Renaissance. The printing press enabled the rapid spread of new ideas and classical texts that inspired Renaissance thinkers. Second, the printing press played a big part in starting the Reformation. Third, the printing press spurred the rise of science. Fourth, the printing press helped start the scientific revolution. The printing press helped people visualize abstract concepts. And fifth, the printing press fueled the Enlightenment. So knowledge really is power. Gutenberg's invention turned ink and paper into power and knowledge into something anyone could hold. Inventions don't exist in a vacuum. They are made by people in a particular time and place. They reflect the needs and values of their society. Let's take a moment to appreciate how far technology has come. We owe a lot of what we have today to inventors like Gutenberg. Speaking of changing the world, we hope you enjoyed this episode of our inventions. For most of human history, night meant darkness. People would go about their daily lives during the day. And once the sun went down, they had to stop. No lights, no TVs, no phones, no AAC, but all of that changed in the 1800s when scientists like Michael Faraday and Thomas Edison helped harness electricity. In this episode, we're going to learn how electricity made our modern world possible. Electricity is all around us today. His father was a blacksmith, but he died when Michael was just 14 years old. Electric current is simply the flow of the electricity. Think of it like water flowing through a hose, but he never built a practical way to light a home or power a machine. In 1878, Edison began working on a better light bulb. His laboratory was the first of its kind, complete with machine tools, a foundry, a chemistry lab, a machine shop, carpentry and electrical testing areas, and even a railroad to transport his inventions. Most electric companies were owned by wealthy investors who charged high prices for electricity. And the people who made the electricity often had dangerous working conditions. Even so, electricity changed everything. What seemed like a far-off dream in the darkest times was now a reality. It was the beginning of a new era, an electric era. He held regular meetings where inventors and other experts would discuss their work and brainstorm ideas. Soon, others around the country were calling their laboratories innovation factories. He worked tirelessly, experimenting with materials and designs. He tried over 6,000 different materials for filaments before finding one that worked. Entertainment venues could stay open after dark. Inventions like the light bulb also sparked innovations in architecture. Before electricity, tall buildings weren't practical because elevators couldn't run without electric motors. Now skyscrapers were possible. Buildings could be made of glass and steel instead of brick and stone, which let more natural light in. Electricity even changed art. Painters no longer had to worry about shadows or lighting. Instead, they could paint any image they imagined. Musicians could amplify their instruments so stadiums full of people could hear them. Writers could type stories and articles on electric typewriters. Kids could listen to music on record players. Everything was changing. The problem wasn't the filament, he discovered, but the vacuum inside the bulb. He soon found that a small amount of gas within the bulb improved the performance of the filament. On October 14th, 1879, Edison and his assistants gathered in his laboratory to test the first incandescent light bulb. When the bulb glowed brightly for 40 hours straight, the team erupted in cheers. The crowd outside the building heard them and began cheering too. Edison had done it. He'd harnessed electricity to banish the darkness. Others had to take his discovery and build on it. Enter Thomas Edison. Thomas Edison was born in 1847 and grew up in Ohio. He was an inquisitive kid who asked tons of questions and loved experimenting. One day he put a brass candlestick on top of a wood stove and closed the circuit by touching the two parts together. When he realized electricity was to blame for the fire that ensued, his mother decided he should focus his energy elsewhere. She bought him a telegraph, which is a device used to communicate over long distances by sending coded messages through electric signals. Edison worked for a telegraph company as a lineman, restoring broken lines and upgrading equipment. But soon he tired of the job and bought his own telegraph equipment to experiment at home. With it, he invented an automatic telegraph that allowed multiple messages to be sent over a single wire. He made improvements on the telephone and the phonograph, which record sound vibrations onto a cylinder coated with wax. These inventions brought Edison international fame and fortune, but he wasn't done yet. When electricity flows through a wire, it's called a closed circuit. If anything interrupts the flow of electricity, the circuit is broken. Today, we use special switches that quickly break and close circuits to turn lights on and off or to start and stop appliances. Back in Faraday's day, though, breaking an electric circuit required removing a battery or disconnecting wires. But if he wanted to demonstrate how electricity could light a bulb or power a motor, he needed a way to generate it. He experimented with different methods and finally hit upon what we now call a simple electric circuit. A circuit has three parts: a power source such as a battery, a conductor like a wire, and a device that uses electricity like a light bulb. When the parts are connected, electricity flows from the power source through the wire and into the bulb, creating light. Faraday demonstrated this with a simple circuit that powered a small motor. He set up the circuit so the motor would spin around. Then he left the room while it was running. When he returned, the motor was still spinning. That's when Faraday knew he'd discovered something truly amazing. The future of the world was electric. Without his father's steady income, Michael's family struggled to get by. He had to leave school to work in a factory making candles and soap. Though he disliked his job, Michael found solace in books. He taught himself about science and earned enough money to become an apprentice at a scientific instrument maker. Soon he was hired as the assistant for a professor of chemistry at a university. There he learned how to conduct experiments and make new discoveries. In 1812, he was promoted to full professor and given his own lab. At age 26, Faraday became the director of its scientific research center, where he continued his studies of electricity. There he built on the ideas of scientists before him to discover how electricity could be used to power the world. We use it to power our homes, our schools, our offices, even our phones and computers. We turn switches on and off to control it, and we pay companies to send it to us through wires so we can use it. But electricity wasn't always here. For most of human history, nighttime meant just that, nighttime. The sun would come up and people would start their days. They'd work out in the fields or in shops or businesses. And at night, they'd spend time with family or relax or try to get some sleep. That is until the Industrial Revolution started changing things. The steam engine was one of the first big inventions of the Industrial Revolution, and it changed life for factory workers. By the early 1800s, Britain had thousands of these engines chugging away in its factories, powering machines that could make things faster than ever before. This led to the mass production of goods, which lowered prices and improved life for many people. But there were downsides. Factories were dangerous, smoky places to work. They often took advantage of child labor and polluted nearby rivers and air. Still, more and more people left farming and moved to towns and cities to take factory jobs. As more people moved to cities, city planners had to find ways to make life more livable. One of those ways was to bring light to the darkness. Cities had street lamps, but they required someone to walk around and light each lamp individually every evening. And they weren't very bright. In 1801, British scientist Humphrey Davy invented an electric arc lamp using two carbon rods connected to a battery. He hung one rod from the roof of a London theater and the other from the balcony above. When he closed the circuit by touching the ends of the rods together, a bright blue light filled the space between them. This was the first electric light, but it didn't last long. After Davy finished his experiment, the light faded. To keep the light burning, he'd have to keep touching the ends of the rods together. So not very practical. But Davy's invention inspired scientists all over the world, especially one man who lived across the sea in a small village called Milan. Michael Faraday was born in 1791 and grew up in England. Faraday's greatest discovery was how to generate electric current. Faraday's experiments showed that electric current could be generated and controlled. That's why he's often called the father of electricity. Edison wanted to do something big, something that would improve life for everyone. He wanted to light the darkness. Edison set up shop in Menlo Park, New Jersey, where he and his team of inventors developed hundreds of new devices. Today, we use electricity to power our modern world. The light bulb changed everything. Cities could stay busy at night. People could work in factories and offices. But not everyone benefited from electricity. Imagine your life without easy-to-fix dinners or your favorite snack foods. Life before these inventions would have been pretty difficult. From canning to microwavable meals to the industrialization of bread, many people worked hard to make sure that we could put tasty, safe food on the table. Here are some examples of how our lives are easier because of food innovations. Before the late 1800s, food preparation was entirely done by hand. If you wanted to help out in the kitchen, you could start by chopping vegetables. The automobile had been around for a while, but it wasn't until now that mass production made it affordable for ordinary people. Instead of having attendants pump gas into cars, drivers could pull into a station, get out and fill up their tanks themselves. This saved time and money, and it made drivers safer by keeping them away from dangerous fumes. You probably learned about how it changed the car industry. But did you know that it also transformed how food is made? This means that if you don't eat it within a few days, it can become unsafe. Even refrigerated foods can only last so long. But thanks to advancements in farming, food preservation, and distribution, we have plenty of food on our plates. So next time you sit down to a delicious meal, take a moment to appreciate the innovative minds that have made it possible. From the farmers who grow our food to the scientists who develop new ways to preserve it, there are so many people working hard to make sure we never go hungry. And who knows, maybe one day you will be the one to invent something that makes our lives just a little bit easier. Imagine buying a juicy steak only to find out that it's gone bad a few days later. You would feel upset and disappointed. But thanks to modern technology, you can avoid this unpleasant situation. One way food manufacturers have dealt with spoilage is by canning. Canning is a process that uses heat to kill bacteria and seal food in airtight containers. This method allows foods to be stored safely for months or even years. It has been used for centuries and is still popular today for preserving items like fruits, vegetables, meats, and soups. But canning isn't the only option. Another common method is freezing. Freezing slows down the growth of bacteria by turning water in the food into ice. It also prevents oxygen from reacting with the food, which can cause spoilage. Frozen foods can stay fresh for weeks or even months. Many types of food are commonly frozen, including fruits, vegetables, meats, fish, and baked goods. But wait, what if you want to eat something fresh? Well, there's also dehydration. This method removes moisture from food, which bacteria need to grow. Dehydrated foods can last for years, and many items can be rehydrated and enjoyed as if they were fresh. Examples include fruits, vegetables, meats, and even soup. Before the assembly line, workers had to do everything themselves. They had to measure, mix, and package products by hand. Not only was this slow and expensive, but it was also prone to errors. But all of that changed with the introduction of the assembly line. Workers were assigned specific tasks to do over and over again. This made the production process faster and more efficient. It also made it easier to train new workers and reduce the number of mistakes. For example, an assembly line for making cans of soup would have one worker adding the soup, another sealing the cans, and a third putting on the labels. This way, each can is filled, sealed, and labeled quickly and correctly. The result, customers got their orders faster and at a lower cost. The assembly line was a big success in the food industry. Companies were able to produce more food than ever before and still make a profit. Plus, customers got better quality products for less money. No wonder the assembly line is still used in food factories today. The first self-service gas station was opened in 1905 in St. Louis, Missouri. It was an instant success, and soon other stations popped up around the country. Before long, self-service gas stations were everywhere, and the old ways of pumping gas became a thing of the past. That meant that lots of families could afford to buy their own car. But having a car meant that drivers needed to stop for gas along the way. Canned fruits and vegetables had to be heated before serving. Packaged dry goods like cake mix required lots of work. So many people preferred to buy fresh ingredients and make their own food. But that changed with the introduction of ready-to-eat cereals. Ready-to-eat cereals were a hit with busy families. They were convenient and didn't require any preparation. This led to even more options being developed, such as ready-to-heat soups and stews. By the 1950s, microwave ovens were introduced, making it possible to heat up frozen meals in minutes. The development of artificial preservatives allowed food products to last longer without spoiling. Together, these innovations revolutionized the way we eat. Families could enjoy delicious, nutritious meals without spending hours in the kitchen, and people were free to explore new culinary horizons without worrying about the mess or the cleanup. And since there were no gas stations yet, people had to get creative about where to fill up. Some drivers would use old oil cans, while others would carry around portable pumps. But these methods were inefficient and dangerous. Drivers had to get out of their cars to pump gas, which exposed them to harmful fumes. Pioneering inventors like John Gorey and Jacob Perkins worked on ways to make life easier through machinery, inventing things like ice cream makers and mechanical calculators. Soon they were joined by others who had similar ideas. They saw that making food was hard work, so why not use machines to do it? By the end of the 19th century, inventors had created several machines that could do what once required human hands. But even if you had a sharp knife, you could only do so much in a day. With the new machine, the dough could be rolled out much faster and more evenly. Another example was the invention of a device that could cut up meat quickly. This made it possible to produce a lot of ground beef in a short amount of time. Also, people found a way to replace butter with margarine. Margarine is cheaper and lasts longer than butter, and it is made by mixing animal fat with vegetable oil and flour. But mixing them up used to be a long process until someone invented a mechanical mixer to do the job. These inventions sped up production and lowered costs. That means more people could afford to buy and eat processed foods. This also made jobs in factories more appealing. And then you need to cook them. For this, you needed an oven or a fire. All of this meant that food took a lot of time and effort to make. So it's no surprise that most meals were eaten at home. And if you weren't good at cooking, life could be pretty tough. But all of this was about to change. The invention of labor-saving devices was on its way. One example was the machine that made crackers. Before it was invented, someone had to roll out the dough by hand, which was slow and tiresome. The first decade of the 20th century saw many new inventions. Then came the first self-service gas station. The idea was simple. In the early 1900s, most packaged foods still needed to be prepared before eating. You might be familiar with the term assembly line from school. While all these inventions help prepare food faster and more efficiently, there was still one problem. Food spoils easily. One of the biggest challenges of feeding a growing population is making sure everyone has access to safe and nutritious food. Today, food factories look more like tech labs than kitchens. Robots now slice, sort, mix, and pack with precision. But automation has been part of the food industry since long before these innovations. Automation makes our lives easier. It's hard to imagine our modern world without pre-packaged foods and grocery delivery services. These things are so convenient that it seems like life without them would be unthinkable to many of us. We could talk about the rise of smart farming and vertical farms, but that's not really the topic of today's video. Consumers expect to get the same great tasting and safe food every time they shop, regardless of where it was grown or processed. Machine vision uses cameras and image processing software to inspect food products for defects, such as blemishes, bruises, and other damage. From the kitchen to the warehouse, robots are changing the way food is prepared and delivered. In the kitchen, robots are now able to perform tasks such as chopping vegetables, stirring sauces, and assembling dishes, which were previously done by human chefs. AI is also being used to develop new food products. From improved efficiency and productivity to new product development and personalized experiences, the possibilities are endless. As technology continues to evolve, we can expect to see even more innovative applications of automation in the food industry in the years to come. By analyzing consumer data and trends, AI systems can help food manufacturers develop new recipes and products that are tailored to the tastes and preferences of consumers. AI is also being used to personalize the food experience. For example, some companies are developing powered cooking systems that can help users create custom meals based on their dietary needs and preferences. This not only saves time and labor costs, but also reduces the risk of human error. In the warehouse, robots are used for tasks such as picking and packing orders, loading and unloading trucks, and moving pallets around the facility. This allows human workers to focus on more complex tasks that require human intelligence and creativity. Robots are also used in the food industry for tasks that are dangerous or repetitive. For example, they're used in the slaughterhouse to process meat, poultry, and other animals. This reduces the risk of injury to human workers and ensures that the process is carried out quickly and efficiently. Another example is the use of robots for cleaning tasks in the food industry. Cleaning is an important part of food production because it helps to prevent contamination and ensure food safety. Robots are able to clean surfaces quickly and thoroughly, which helps to reduce the risk of foodborne illness. They're also able to work 24/7 without taking breaks or needing to be cleaned themselves, which saves time and money. One of the most significant benefits of using robots in the food industry is increased efficiency. Robots are able to work faster and more accurately than humans, which helps to reduce waste and improve productivity. For example, a robot arm can pick up and place items with greater speed and accuracy than a human worker, which reduces the number of errors and the amount of wasted food. This technology is used to ensure that only high-quality products reach consumers. For example, AI-powered robots are now able to perform tasks that require a high degree of precision and accuracy, such as inspecting food for defects. AI is also being used to optimize the production process. By analyzing data from sensors and cameras, AI systems can identify inefficiencies and suggest improvements. This helps to reduce waste and improve productivity. For example, machine vision systems are used to inspect eggs for cracks, bruises, and other damage before they are packaged. This helps to ensure that customers receive fresh, high-quality eggs. Machine vision is also used to inspect fruits and vegetables for blemishes and other damage. This helps to ensure that only the highest quality produce reaches consumers. One of the benefits of using machine vision is that it is much faster and more accurate than traditional inspection methods. Machines can inspect food products in real time as they move along the assembly line. They can detect defects that are too small or subtle for the human eye to see. To meet this challenge, manufacturers rely on a combination of traditional inspection methods and cutting-edge technologies. One of the newer technologies used to ensure food safety and quality is spectroscopy. This method uses a device called a spectrometer, which shines light onto a sample of food and measures its chemical composition. By analyzing the data, manufacturers can detect contaminants, verify the quality of raw materials, and ensure that products meet safety standards. Spectroscopy has been used to detect salmonella in chicken, E. coli in beef, and listeria in processed meats. It can also be used to check for the presence of allergens such as peanuts and tree nuts in food products. One of the benefits of spectroscopy is that it's a non-destructive testing method. This means that the food can be tested without being damaged, which reduces waste and saves money. In addition, spectroscopy is fast and accurate, which helps manufacturers make informed decisions about food safety and quality. Overall, the use of spectroscopy in the food industry is essential for ensuring the safety and quality of the food supply. By using this technology, manufacturers can protect consumers from harmful contaminants and provide them with the assurance they need when they purchase food products. Instead, let's start after the food is harvested and processed. And the reason we can enjoy the luxury of having everything at our fingertips is that somebody has automated the process. In fact, food processing was one of the first industries to adopt automation technology. The earliest food-related patents were for apple peelers and corn shellers. They were simple machines, but they changed the game by doing repetitive tasks faster and more efficiently than people. And ever since then, we have continued to find new ways to automate the processes involved in getting food from the farm to our forks. Sensors check for freshness, and artificial intelligence systems track quality in real time. No breaks, no mistakes, just fast, efficient production 24/7. This isn't science fiction. It's how your snacks, frozen meals, and grocery items are made every day. Automation helps feed billions, reduces waste, and keeps prices low. From hand tools to smart machines, we've come a long way. When you think of an automated system, what comes to mind? Maybe it's self-driving cars or home voice assistants. But why is this? Why do we keep automating the processes involved in making and distributing food? Well, let's start with the obvious. In the food industry, automation is used all along the supply chain. From planting the crops that end up in our food to packing and delivering the finished product to our local stores. For example, robots are now being used to pick and pack fresh produce in some places. So even our fruits and veggies are getting the robotic treatment these days. Automated guided vehicles, or AGVs, move large objects around warehouses and factory floors, allowing workers to focus on more complex tasks. Meanwhile, other technologies such as machine vision, robotics, and artificial intelligence help with quality control, reducing waste and improving efficiency. So, let us take a closer look at how these machines work and how they make their way into the food we eat. One of the biggest challenges in the food industry is ensuring that products are consistently high quality. Another innovation that has revolutionized the food industry is machine vision. Now, let's talk about one of the most popular and fastest growing areas of food automation, robotics. Let's not forget artificial intelligence. AI is being used in the food industry for a variety of applications, but it doesn't stop there. So, as you can see, automation is transforming the food industry in many ways. If you've seen any of these systems in action, let us know in the comments section below.